As you were saying, Tristan, right, we have to use the midpoint as an approximation for each class interval. So what's the midpoint for the class interval 2 to 5? 3, 3, 3.5. Midpoint for 6 to 9, 7.5. Midpoint for 10 to 13. And notice it just going up by 4. So we can just put our 15.5, 19.5. Good. Now this is our frequency f, don't? So now we need our f times x column, right? So 7 times 7.5, 50 something. Huh? Alright, so 52.5. Now 11.5 times 9 is what? 11.5 times 9? So that's our 103.5. Then we got 15.5 times 8. And that gives us 124. And then 19.5 times 4. That is 78. So now we can go ahead and work out the mean by adding up f times x. When we add them up, what we get? Somebody add them up quick, quick. We add them up quick, quick, what we get? I'm not hearing nobody. We add them up, what we get? Okay. Alright, 365. Alright. So 1 year, okay, I catch it. 365. Now divide by the sum of f. What's the sum of f? 30? 32. So divide by 32. Divide it by 32 now. How much? 12.17. So that's the mean. Now, remember that it's in 100,000. So we have to multiply it by 100,000 and we get, how much is that? 1,217,000. So that's the mean income for the year for entrepreneurs in Jamaica from a sample of 32. All right. Now, the median net income. Yeah, yeah, the sum of F, 32. Oh, it's 30. Oh, sorry. Why I heard 32? I didn't add it, is what I hear. Sorry about that. So 30. And that is the mean income. All right. Median was Lamario, right? Median is yours. All right, take it away. How we gonna find the median now? Good. Good. So 10 to 3. Good. So just for everybody else to see, remember cumulative frequency 2, add 2 to 7, 9, 9 to 9, 18, 26, 30. So 15.5 is indeed in here. Good. So now that it's in there, Lamar, 10 to 13, what are you going to do? Good. So 9.5 plus 30 divided by 215 minus. No, so remember, up to is just before. So just before the cumulative frequency, just before the median class. So just before the median class, the cumulative frequency was at 9. Right? 9 right there. Alright, always remember, in the bracket will never work out to be negative, alright? Alright, now divide by frequency of the median class, very good. 9 multiplied by class size 13 to 10, that is 13.5, yes, 4. Good. Punch that in your calculator and tell me what you get. 12.16. So 12.16, how much is that now in 100,000? Very good. Notice the mean and the median close together. Alright? Close together. And we started looking at skewness. Today we'll continue skewness. By the way, this is what already? Positively skewed or negatively skewed? Negatively skewed. What's the formula for skewness? Or another one, the 3 in bracket mean minus median. So is that negatively skewed? No, positively skewed. Mean minus median, positively skewed. Cool. Let's work out now the modal net income. This one is for Jaden. Jaden, this is yours, number 3. 10 to 13, good. No, remember the formula we just said for mode? So what's the formula for mode again? Lower class boundary plus delta 1 over delta 1 plus delta 2 is class size. This is the formula, Jaden, for mode for group data, alright? Alright, so as you rightfully said, we had the 9.5, the lower class boundary for the modal class. Now, delta 1, as we said, this means the change from the class before the modal class to the modal class. What's the change in frequency? Yes, 2. So delta 1 is 2. Now, delta 2 is a change from the modal class now to the class, the frequency for the class just after the modal class. What's the change? 1. Very good. Times the class size of the modal class. And what's the class size? 4. Good. 4. So that works out to be what? You're gonna observe. Yeah, class size is 4. How we get 4? Remember class size, the formula for class size is upper class boundary minus lower class boundary. Right, Israel? So 13.5 minus 9.5. And this is how much? How much you get, Jaden? 12.16. So same as above. Right there. So that is, when you convert it to 100,000, it's how much? Exactly. So it's 1,216,000. So again, it showed that mean minus mode positively skewed. Alright, so mean and mode just happen to be the same in this example, coincidentally. Alright. Okay, so that's a slightly little bit higher, but that's fine. No standard deviation. So gentlemen, next in the notes now is to look at the measures of spread. We started last week, and so I'm not going to go through these measures of spread. Not going to go through range, not going to go through interquartile range, not going to go through semi-interquartile range. The only one we're really focusing on is standard deviation and variance. Again, these are some stuff we did in ADMA. However, gentlemen, now we put a little more emphasis in how we approach these questions. All right? So in AdMath, you could have used any one of them formula and get it right. You could use this, 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 this. You could use any one of those and get the question right in AdMath. All right, but knowing apply, they're expecting you to know when to use which one. Now, gentlemen, here's the thing. Lamario, only time you divide by n is when you're finding the standard deviation for the population or when the sample size is really small, less than 10. Let me say it again. The only time you divide by n is when the sample size, oh, this was bar x, xi minus bar x. Computer, type that, xi minus bar x. We'll fix that. Yeah. xi minus bar x. So again, Lamario, only time you divide by n is when the sample size is small, less than 10, or you're computing the standard deviation on the population. We already talked about what population is. So if Jaden wants to find out information about how are students at Jamaica College feeling about education, if Jaden interview everybody in the school, that is the school population. And so if Jaden interview all 1,800 students, you divide just by n because that is for the population. He got information from what? The entire population. That's when you divide by n. Now you divide by n minus 1 when you're doing it for a sample now. So when the sample size is large, meaning more than 10, or let's say Jaden couldn't get now everybody in the school, but him doing only 900. That is when we divide by n minus 1. So instead of divide by 900, we divide by 899. So use it when we're finding standard deviation for a sample to use that as an unbiased estimator to be our standard deviation for the population. All right? So we'll use this one for sample and this one for the entire population. Is that okay? Now, gentlemen, these formulas are literally the same. All right. Only thing is that they transform this one. So I like us to see the transformation. All right. I'm going to show us the transformation. So for the first formula, we have the standard deviation is equal to the sum of xi minus bar x all square divided by n square rooted. I'm going to ignore the square root for now, alright? We're ignoring the square root for now. I'll put it on right after. We know for expand, I'm just showing you how they get the formula, guys. If you're to expand this, this would become the sum of first term square, so it's xi squared, minus twice the product of the two, so it's 2xi times bar x, plus second term square. This becomes now plus bar x being squared. This is what we want now, over n. Okay with that? Now this part now gentlemen, look at this. I want it to make sense with numbers, so I'll do it on a blank page way around here. Look at this, right? If I'm adding up different numbers, look, let's say I'm adding 1 to 5, and then I'm going to be adding 6 to 10, and then I'm adding 11 to 15. Follow what I'm saying? Follow what I'm saying? So let's say we want add 1 to 15, right? You can separate adding 1 to 15 into three different summations. That's what summation mean. So what we're saying now, gentlemen, is since we can separate adding, instead of adding 1 to 15, we can add 1 to 5 and get that result is 5 and 4 is 9 and 3 is 12 and 15. We can add 6 to 10 and we can add 11 to 15. That can give us the same as adding from 1 straight up to 15. So just like regular summation. So we're saying we can separate this then and say it's the sum of the first one, xi squared, plus the sum of the second part. But since right here is a minus, we can just put minus the sum of 2xi times bar x. And then we have plus the sum of bar x being squared. And remember, this is all being divided by n. Everybody okay with that? All I do is separate it. Instead of adding it straight, you can add this piece, then plus the addition of this piece, then plus the addition of this piece. That makes sense? That's all. I just distributing the summation sign. Yes, you can. Yes, you can. Yeah, it's really cool. All right, now, gentlemen, right here, so now this is where it gets a little bit nice now. So now we have to use up our imagination. So I'll come back around here. Follow what I'm saying. Let's say I was asking Tristan, I said, Tristan, find the sum of, let's say, find the sum of 5, 5x, and I want you to go from x equal 1 to 5, right? Then Tristan is going to plug in x as 1 and say it is 5 times 1, then plus 5 times 2, then plus 5 times 3, then plus 5 times 4, then plus 5 times 5. Don't agree with that? And so that would be 5 and 10 and 15 and 20 and 25. I think that's 45, 60, 70, 75. So this is what we get. But then now, Israel might want to show off him skills and Israel might say, but Tristan, 5 not change, why you never factor out the 5? So Israel might say, since we're summing from x equal 1 to 5, or 5 times x, Israel just factor out 5 and then say, why not just find the sum from x equal 1 to 5 of x? So we're saying it is 5 times, plug in x as 1, plug in x as 2, plug in x as 3, plug in x as 4, then plug in x as 5. If you were to work this out, you realize you get 9, 12, same 15 times 5, which is the same, 75. So follow what we're saying now. Gentlemen, once it's a constant, you can factor it out. Since it's a constant, you can factor it out. The mean would have worked out to be a constant. The mean would have worked out to be a what? Constant. So when you plug in the different xi's, the mean remain the same. So what we're saying in the formula is right here we can factor out 2xi because this piece is a constant, don't? So that is now Right here, 2xi, sorry, not 2xi, xi is not a constant, bar x, so we can factor out 2 times bar x. Sorry about that, thank you. So factor out the 2 and the bar x. So this is now the sum of xi squared minus 2 bar. By the way, you don't need to know the proof. I'm just showing you how they generate the next formula. So 2 bar x, repeat, no proof. It's so yeah, but I like when we know the proof since we're pure math students, right? Plus, plus now the last part is the sum of bar x squared. But we're going to observe something about this sum of bar x squared. Now remember, bar x squared, if bar x is a constant, wouldn't bar x squared be also a constant? Yes, so just factor out bar x squared. Now you leave now just the sum of 1. Alright, no problem. Look what I'm saying. Look at this, Jaden. Let's say I ask you to find the sum of 7 square. And I say I want you to do that from 1 to 10. I want you to do that from x equal 1 to x equal 10. Look at this. You now have the x plugging in. Right, Jaden? So you're just adding 7 square 10 times, don't? So you just add 7 square 10 times. Which is really just 49 times 10, which is 490, right? Look what we're saying, Jaden. Couldn't you then just factor out 7 square from the start and add this of the sum from 1 to 10 of 1? So notice you're adding what? 1 10 times. So now you have 7 square times. You're adding 1 10 times. Now when you add 1 10 times, you get what? 10. And then the 10 times the 49. That's still 490. Yes, so because once the constant is being squared, you can also factor out the whole of that because the whole of that is still a constant. Makes sense? Yes, because when you square a constant, you get also a constant. No, remember right here is just bar x square, you know. This is just bar x square. We're just factoring out all of this constant here. Okay. Alright, so that's all we're doing, guys. We just factor out this because bar x is just one constant. We don't business what bar x is. We just know we don't get a constant, a number. But since you have that number being squared, you can just factor it out. So factor it out, and we have now the sum of 1. Now remember, there would have been n terms in, when you're doing standard deviation is with n terms, right? It's n terms, right? So you're adding 1 n times. If you're adding 1 n times, what we're going to get? N, very good. So the sum of 1 right here, so that part is really just n. So following the next line, this now works out to be the sum of xi square over n. Look what I'm doing now. I'm going to separate them. Minus, this second part now is 2 bar x. I don't know why I keep disappearing. Minus 2 bar x times the sum of xi over n. Is that part okay too? I just separating and put each over n. Then I have plus bar x squared times, we just established that the sum of 1 is what? N over n. Okay with this? Now look at this. The n would cancel the n. The summation sign, we made it disappear because the sum of 1, n times is just n. So now the ends would cancel. And follow this now. Israel, look at this. What's the sum of xi over n, Israel? This is what? Tristan, what's the sum of xi over n? Tristan gone? Alright, Lamari, what's the sum of xi over n? That's bar x. So, isn't that the mean bar x? Yeah, this is bar x. We said bar x is the sum of xi over n. Just to go back to the notes, first thing that we started with. See it here? Bar x is what? The sum of xi over n, right? Everyone okay with that now? So right here, this is bar x. So look what we end up get. This is now the sum of xi square over n minus 2 bar x times bar x. Bar x times bar x is what? So this become 2 bar x square. But then we add a bar x square. Now negative 2 bar x plus negative 2 bar x square plus bar x square is what? Negative bar x square. So the final thing works out to be the sum of xi square over n minus bar x square. And so, gentlemen, now I just can add on the square root for everything because remember we had removed it just for simplifying under the square root. And now this is how they end up get this formula. So just to put the square root at the final thing, this is how they get the standard deviation is the sum of xi square over n minus bar x all square. You don't need to know the proof. You do not need to know the proof. This is just the formula that you can work with. Where we are in the notes. Here we are. So this is how you can use either this one or you can use this one. Alright? Now in the interest of time, I'm not going to show the simplification with dividing by n minus 1. But just know when we do the same expansion, it's going to simplify to be this right here. When we expand out and then do our factorization and take out our constants and all of that stuff, it will work out to be this. Cool? Now, gentlemen, the only difference now with group data, because this is what we use for raw data, by the way. These formulas we use for raw data. Now, not all the time you're given raw data. You're going to be given group data where you're going to have frequencies. This is the formula I use for frequencies. Xi minus bar x square over n. And remember, we use this when it's for the observation or when the sample size is small, n is less than 10. This is group data formula again when it's n is less than 10. And also if it's for the population. And you use this group data formula, the one that I would have let us use in AddMath. We use this one when we're working with sample size. Sample, and the sample is usually it's going to be large. Yes. Xi. So Xi is the Xi is just the values for Xi is just each data point. Xi is just each data point, alright? So we're going to put this to the test now. So of course, the best way to do standard deviation is to actually do questions. By the way, just to refresh our memory, because Aman didn't do AddMath. So I am here speaking and Aman is wondering what is standard deviation, right, Aman? Yeah, so sorry about that, all right? So, all right. All right, so just to not get carried away, so I'm on standard deviation. What this does, it measures how much on average each data value deviates from the mean. That's what it does. So for example, I'm gonna you do an example. So Aman, look at this. Let's say, for example, in applied math, this is your grades, right? Let's say you get 80, 83, 71, 65, and 85. These are your 5 test scores, right? Right, Aman? What's your average? What would be your average for applied math from the 5 grades? Yeah, but work it out. There's a reason why I want you to tell me. 76 again? All right, 76. Now look at this, Aman. Notice that your first score deviated by 4, right? So from 80 to 76, your first score deviate from the mean by 4. Your second score deviate from the mean by what? 7, right? The third score deviate by 5. And the fourth score deviate by how much? 76 to 65 is 6. That's how much? From 76 to 65, Aman? Yeah. What's the difference between 76 and 65? 11. So that means say 65 deviate. That's what deviate mean in a difference. So 65 deviate from 76 by 11. How much does 85 deviate from 76? Yeah, 9. So notice that your first score deviate from the mean by 4. Your next one deviate by 7. The next one deviate by 5. Next one deviate by 11. Next one deviate by 9. If you add them up and divide by 5, this gives you what? Average deviation, don't? This is what we call the standard deviation. So look, average deviation 4 and 7, 11, 11 and 5, 16, 16 and 11, 27, 27 and 9, 36. 36 divided by 5 is 7.2. So on average, your scores are deviate. Each score you can expect to deviate by around 7, don't? So look what we're saying, Aman, follow. What we're saying then is if you deviate by 7, right, then we're saying if your mean is 76, we're saying on average your scores them supposed to be between either 7 less or 7 more. So most of your scores gone there in between. Subtract 7 from 76, you get 68.8 to add 7.6 to 76, you get 83.2, right? So this is where most of your scores lie. That is what standard deviation measures. It measures how much each score deviate from the mean. So then last year, Kanye asked the question, so sir, if it's so simple, why they make the formula look so complicated? You're asking that same question to, right, Aman, I'm assuming, right? Because if it's so simple, why we didn't do subtract and do all of that? Why instead of do all of this square and square root? No, the square and square root. Jaden, could you tell him why we do square and square root if you remember? Alright, so remember now, right here, so we didn't take into account the positive or the negative with this method. This method is very flawed. This method is what? Flawed. Because look at this. From 76, the difference between 80 and 76 is 4 indeed. Difference between 83 and 76 is 7. But when your score reach below the mean now, the difference shouldn't be positive. Shouldn't that be negative 11? And this be negative 5? Because notice we're subtracting 80 minus this give 4. 83 minus this give that. 71 minus that should be negative 5. 65 minus that should be negative 11. But then if we do that, we're not going to get the true approximation of our deviation. We're not going to get the true approximation of how much we can expect each one to deviate by. So in order to eliminate the negatives, what we do is square the value and then we'll square root it back. See it? So that is why, so notice, you get 7.2. Look what we're saying. We're saying the true formula, remember, is the sum of xi minus bar x squared over n square rooted. So we square it, then square root it back. So we're saying the standard deviation would be, we square the difference, which would be 4 squared plus 7 squared plus negative 5 squared plus negative 11 squared plus positive 9 squared. Right, Amon? Then we divide it by the 5, then we square root it back. Look at this now. Gonna be roughly close to the 7 now. But this is the correct way to do it in order to eliminate the negatives. So square root, 4 square we know is 16, 7 square we know is 49, negative 5 square we know is 25, negative 11 square is 121, 9 square is 81. Divide by 5. This will give us the true value now. 7.64. This is now the true deviation, not the 7.2. Because the 7.2 ignored whether it was less than the mean or greater than the mean. This take account for that. And then in order for it to not affect our calculation, we just square it and square root it back. So this would give us the 7.6. That's the true standard deviation. So that would be the true standard deviation. So if somebody did this on an exam, even though technically by the definition of standard deviation it's correct, but because it didn't take account for the fact that the deviation can be negative, right? You're just looking at absolute deviation. This wouldn't be correct. So if you do this in an exam, depending on how nice the examiner is, if standard deviation is 6 mark, it may give you 1 or 2. So it might give you the 1 for the answer. Most of the answer is correct, roughly in the same ballpark, but definitely they're not gonna give you any marks for the work you know. Alright, so that is why I will use the formula. Cool? Cool. Alright, so let's go and do some standard deviation now. So this question right here, it wanted us to work out the standard deviation. So let's do it. Alright, this blank document full. So let me open the next blank document. Blank. We're just going to copy that table and find the standard deviation. And we're going to utilize the two different formulas. Do I want to? Oh, no, let's not use the two different formulas. We're just going to use one. So by the way, from that table, it is group data, right? The table is group data, right? So since it's group data, which of the standard deviation formulas we're going to use? Very good. We're going to use the one with the frequency in it. Now, first and foremost, are we going to use one that divide by n or one that divide by n minus 1? I'll let you see the question again. You can tell me if we're going to divide by n or n minus 1. Very good, because the word tell, we see it here, big old sample, right? there's no way we could have gotten there's no way we could have gotten all the entrepreneurs in Jamaica. All right. But what if this was saying entrepreneurs at Jamaica College? Then the 30 could have been the 30 entrepreneurs in JC. Might be no more entrepreneurs are here in our school, right? All right. So that's what we have to look out for. So in this case, it's a sample. So we're going to have to use one where we divide by n minus 1. So in that case, this is the formula we're going to use since it's group data. We're using this one, the one that we're used to from ADMA. Alright, so this is the one we're going to use. Why the blank document don't open yet? Let me try something again. Open. What? Oh, here it is. This is it. Oh, just moving it over here. So I'm closer to the question. Alright, I just want to copy the table back in the blank document. Alright, so two, because it's not so clean anymore. Alright, Lamar, you remember what was in the table? Barely. Alright, so tell me, net income. I remember it was 2 to 5, and then 9, and then 14 to, then 18 to 21. Cool. And then, of course, our frequency. I remember this was 2, 7, 9, good, and 4. So now we're going to use the standard deviation formula that tells us standard deviation is equal to the square root of, let me not write it so close, because I'm going to need to extend the table. So the standard deviation is equal to the square root of the sum of fx square minus the sum of fx all square divided by n over n minus 1. Now, Aman, no problem. If you cannot remember the formula, don't worry. The formula is on the formula sheet. So I'm going to download the formula. A matter of fact, let me show you right now. Keep and the pure mathematics formula sheet PDF search. I'm going to download it and upload in the classroom. Gentlemen, you do not need to remember it because it's on the formula sheet, but I would prefer if we know it. I can't take this with tribe. They're going to ask me to, they always ask for some holy stuff. Download now. They're going to ask me to upload 5 documents to download. I'm just going to upload 5 documents. That's what I don't like with this website. You have to upload 5 documents before they allow you to download. Anybody download anything from Scribe? Yeah, so Scribe, it's, let me see. I don't like uploading my personal stuff, so I will upload some track and field documents. How much is that? 1, 2, 3, 4. 1, 2, 3, 4. I need one more. Why is it taking so long to read? So by the way, this is another website that you can use to download like textbooks. You just search for what you want. The only thing with this website, Scribed, is that you have to upload 5 documents each time you want to download a document. So essentially, basically, you have to, give to receive. That's all. Yeah, yeah. Each time you have to give 5 documents. Well, it doesn't matter the file size as long as it's 5 different documents. I did upload. Why it don't give me it now? Talking about I did upload the 5 documents. Alright, I think they're having some network issues. Oh boy. I upload my 5 documents already. I'm not doing that again. Somebody else must give it away. Please click on each of the following that a person normally wears on their foot. Imagine, why do websites do stuff like this? Exactly, that doesn't do anything. But see it here now, I have it open. I'm gonna download it and save it. So download, here we are. Alright, so I'll upload it in the stream after our session. Don't want to waste too much time. But here it is. We're gonna learn this in module 2, normal distribution. We're gonna learn T distribution is for unit 2. We're gonna learn chi-square. This is the one I'm telling you usually challenge person. We're gonna learn that in module 3. Don't need to know the random numbers table. That's from 2010. They don't need to know that anymore. This part is for pure math, quadratic formula. They give you arithmetic series, geometric, binomial expansion. They give you combination. We're going to learn this in Unit 2 combination. They give us summation, complex numbers, Unit 2, pure math. These are all Unit 2, trigonometry, Unit 1, arc length, Unit 1, area of triangle, Unit 1, trig identities, Unit 1. Statistics, look at this. Mean, they give us sum of fx over sum of f. See it, Aman, I really was showing, I really brought out this for Aman, because, yeah, so you don't have to remember it, we need to know it. Mean, sum of fx over n. Standard deviation, as we said, the sum of f in bracket, xi minus bar x squared over n, and n is the sum of f. We're going to learn product correlation coefficient, don't worry. So notice this standard deviation right here, they didn't tell you it is for what. So you would have to know that this is for which one. Is this for population or this is for sample? No, not sample. It would be sum of f minus 1 if it is sample. This is for population. Alright? So notice it don't specify. That's what I don't like with the formula sheet. They do not specify. Alright? Again, they give us product moment correlation coefficient. We learned this in module 3, which is regression analysis. Oh, I'm so stupid. I remember I uploaded in the class stream. I uploaded the syllabus. The syllabus also have the formula sheet. So gentlemen, I hope you'd have been going through applied math syllabus. Formula is always in the syllabus itself. So I don't know why I didn't start with this. So the formula sheet is on page, let me see, content, applied math. Yeah, repeat. McLaren. Don't worry, we're gonna learn that next year. That's unit 2. So that's something for Tristan to be asking. You don't worry. All the way to next year. The formulas, the back. It's only sad that we didn't get to start applied last year, so Tristan could have been doing unit 1 and unit 2, right? But that's it. Formula. They didn't. I think they do, I think Mr. Tomlinson is the one that I don't know. Well, at least he's the one that would have. Oh, I know. Usually Mr. Tomlinson does it. He's not around anymore. Where find the formula sheet again? Can't we look at table of content? Table of content. Skills, aims, structural syllabus, outline, miscellaneous symbols. That's where. Miscellaneous. Yes, Antoine. Good evening. Alright. Applied math notations, regulate. I know the formula sheet was somewhere in here. So I guess you're gonna have to look through. I know they give it somewhere here. But I want you to find it which page specifically. It's not there, not there. And it's so sad that even Antoine could have done applied last year and had another one sitting pretty. And we should have been doing unit 2, right, Antoine? Where is it, man? I see the notation. I don't see the formula sheet. I know it's here, man. I know it's here. Was it with the book? No. Alright, don't worry. I'll find out the applied math formula sheet and show you, Aman. But Imagine, waste 20 minutes looking for it and didn't find it. Alright, that's the Cape Pure Math one, and a little bit of applied is on it, but we want to look at that. Alright, so as we were saying, we were doing this question now. We want to find out the standard deviation. So we use this formula for standard deviation since it's group data. So the first thing we're going to have to do now is we're going to have to, of course, write down our xi, and xi again, Tristan, is what? Midpoint. We use midpoint to represent our x values, right? Right, Tristan? So 3.5. I think this was 7.5. This was 11.5, 15.5, 19.5. Alright? Notice in the formula we're going to need f times x squared. So you need to have a f times x squared column. We also need a fx column. So let's work out a fx column first. Well, in this case, it's a row. Usually it's a column. Then here, so we work out a fx squared. So fx will multiply 2 times 3.57. 7 times 7.5, I think that was 52.5. 9 times 11 and a half. How much did we say that was again? 103.5. And 8 times 15.5? 124. And 4 times 19.5, what is that? 78, yes. Now you need fx squared. So you work out x squared, 3.5 squared, then you multiply it by f. So in this case, you're going to work out, just to show you, work out f, 2 multiplied by, so 2 multiplied by 3.5 squared, bam, you get your 24.5. The next one, frequency being 7, 7 times 7.5 squared, we'll end up get 393.75. Then 9 times 11.5 square. What is that? What's 9 times 11.5 square? 1190. Alright. Next one now. 8 times 15.5 square. And then 4 times 19.5 square. Good. Now find the sum of fx and the sum of fx square. Sum of fx. That's for which one? Oh, so when you add down here, you get, well, you add them separately, just these 5 you add. No, add these 5. Yeah, these 5 I want. Yeah, require a little bit of focus, but no worries, it's easy. 5,051 and how much? 5,051.5. Now work out the sum of fx. How much is this? The sum of fx. 365. Good. Now we can work out the standard deviation. The standard deviation is now the square root of, we already found out the sum of fx squared, that is 5,051.5, minus the sum of fx, which is 365, that is being squared. They will divide it by n. N, remember, we said n was 30. The sum of f is n. And so n minus 1 is 29. This is all we need to work out. Now, I'm recommending that you get one of these calculators, alright? So look at this. One of these calculators, you can put everything in it one time. 5,051.5 minus fraction button. Open the bracket. 365. Close the bracket. Squared over 30. It will divide it by 29. Punch that in the calculator. 4.58 or 4.59. So 4.59, that's the standard deviation. 4.59, that's the standard deviation. And remember, this was in 100,000. This was in 100,000. So we can't go give them this. We can tell them now. We write down our answer now. Oh, that's not the worksheet. Here it is. So now we're going to tell him that the standard deviation is, what is 4.59 in 100,000? That's how much? How much money is that? Yes. Good. 459,000. That's a standard deviation. So that's a huge deviation. 459,000. That's a standard deviation. Alright? That's that. Easy, right? Time consuming but very easy. This is way easier than what we're doing in pure math, don't? Nice. So, now we review standard deviation. Now, gentlemen, variance. Now, I have never seen from applied math start from 1996 to now. I've never seen they ask a question on paper two with working out with variance. All you need to know about variance is that variance is the standard deviation square. Usually they test this on the multiple choice, but don't worry, gentlemen, before the exam, before paper one, we'll go through every paper one from 2012 come straight up to 2021. Alright? We're gonna go through all of them together and make sure so we're good. Because trust me, everybody here is a half a place in apply. Right? We have to place. All of us have to place. We have the skill set, we have everything. We have to place, gentlemen. I'm telling you. No school not gonna let you be as half as prepared for apply like how we gonna prepare. Alright, so we have to place. But paper one, that's for later date. Variants usually come on paper one. So now, everything now, we can tackle the entire question too. So gentlemen, analyzing data is question two. Working out mean, mode, median, standard deviation, trim the mean. Antoine, see I start recording whenever we're online. We're going to record so I know that sometime you might don't reach home from work yet. So we're going to post the recording in the stream if you can't make it. Alright, Antoine? Antoine gone already? Alright, we're gonna go through some question tools now, gentlemen. So let me open up Intimath past papers. I don't upload the more recent papers yet because The homework is really taken from the more recent papers. Where I put this? No. So in the worksheet that I upload, you can do the rest of questions for practice. Now, gentlemen, I also worked them out already. So every question you see right here, so in this worksheet, I have the answers for them, all right? So what I'm saying is, gentlemen, do them whenever you want. The number 4, the number 5, the number 6, the number 7, the number 8, the number 9. All right. When you done all of them and you do them sometime throughout the week and you want to check your answers, just ask me and I'll send you the solution. All right. But only reason why I don't upload the solution in the stream because I want you to do the question then. That's the only way we get better is if you practice the question then. Make sense? All right. So now we're gonna look on some question tools. And as I said, we'll finish module 1 now. We finish module 1. So now, and next week, of course, is our 6 weekly test. And this is coming on our report card next week, Sunday. Don't worry, Antoine, we'll work out. If you can't make it Sunday, we'll work out how you gonna do the test. Don't worry. You did do it Friday or something. Alright. As I say, we always start from 2010, gentlemen, because every paper before 2010 is irrelevant because you'd have noticed some topics in Unit 1 that's no longer there. They changed the syllabus 2010. Alright, so it's best to start from 2010. So that's why I'm skipping. 09, we're at 2010 now. Now, let's just reverse it and go backwards. Let's start from the last one in this booklet, which is 2016. Then we'll go 2016 and 2015 and so forth. Alright, so this is 2016 Unit 1. Look how easy this is. Unit 1, Paper 2. As I said, everybody is supposed to get full marks in Module 1. Full marks. Alright? I want to start with some calculations. I guess we can just go through the full question. Full Module 1. So gentlemen, this is 2016. Let's go through the full Module 1. Jaden, you can read the question for us? And 2, 3, 4. Very good. All right, so let's go. Now, population of interest. What are we interested in? Still, all right, so the number of CSEC. Now look at this, Israel. Key thing, the data collected were classified the following 3 variables. The population of interest. Population is what? Population is what? What are we interested in find? By the way, what the question say? Random sample. Sample always come from your what? What is the population? Exactly, that's your population, gentlemen. Fifth form students, but just to be certain, add on of a certain school. So fifth form students. Pen stop right. Fifth form students. All right, Israel. Next one, yours. A sampling method. What's a sampling method we use? How did we collect the data? Very good. So this is which type of sampling? Very good. So this is just we just randomly them already tell us what we did. So this is yes, random sampling. No, 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 just random. Simple random. So just as Jaden is saying, we want to show them it's SRS. It's simple random. We just take 25 randomly. It didn't tell us how they got the 25 randomly, but they already tell us the method. The variable which is qualitative. What's qualitative? What's qualitative again? Very good, Lamar. Somebody studying the notes. All right? Somebody studying the notes. So which one of these is qualitative? Why? The favorite. We cannot order this logically. If Israel said the best subject is pure maths, and Jaden said no applied maths, there's no way we can list. Yeah. So why? Good. And if you want, you can actually write out what it back is. But because it says the variable, we can just put the letter. All right? Now it says a variable which is continuous. Which one is continuous? Which one? Very good. Z, the distance. We can put the distance each student travel from home to school in categories. So maybe Antoine is traveling the distance is maybe 1 to 5 kilometers, maybe for somebody is between 5 to 10. It's continuous data. Once you put it in group data form like that. The variable which is discrete, X. That's it. Easy 5 marks, don't it? Too soft, don't it? Too soft. Now look at this. Gentlemen, I'm not going to do pie charts. I would have uploaded worksheet, video links to this. Not going back through this stuff from CSEC. All right, so Lamar, read the question for us. Hmm? Yeah, you can just skip it. All right, so let's do part I. So, Tristan, you ready? Hold on to part I, Tristan. Tristan here? Tristan, hold on, find the angle, the sector angle that represent persons who love potato. No, it's not circle theorem. It said 32%. Circle theorem in applied maths, Tristan. Tristan, how much did angle in a circle add up to? So 32% of 360. 32 over 100. Basic, don't? So what you did expect to do? I notice they say give answer to the nearest whole number, so we're going to just put 115 degrees. All right, Lamar, you ready? It tell we said 10% from home love yam. Determine the total number of persons who live in the home. So we know say this represent 10 people, right? What we gonna do now? They need to what? So 1.8% is one person. So I didn't just say 100% is X, then cross multiply, and that is 100. Yeah, it's the same thing. It's the same thing. We don't cross multiply. Why you don't cross multiply? All right, no problem. But it's the same principle. But yes, Lamar, that's right. So you have the 100 and you divide it by 1.8. Now how much you get? 55.5, but we round up, so it's 56 persons. So that's good. So 56 persons living in the home. Now, gentlemen, again, maybe Jaden want to show off some skills, right? Because again, this is so boring. So what we can do is, of course, maybe you want to show them, say, all right, maybe you want to work with the sector angle. I'm just showing you different ways we can tackle it. So instead, if 18% is 18 over 100 times 360, and that is 18. Yeah, that's also, we're going to do that also after. We can do that as well. As I said though, just be creative, just for do something different. We find the sector angle first, and we'll get way. Yeah, as I said, don't worry about apply, don't worry. So this is 64.8 degrees. So as we say, we know that the number of persons for yam, so 10 person, we can tell them, say 10 person, that go to 64.8 degrees. And then 360 is the total for the sector, go to x, cross multiply again. So x is 3600 divided by the 64.8. Similar to Lamario approach, right? So we just do now the 3600 and we divide it by our 64.8. That's so basic. And we get the, see it there again, the 55.5. Or you can do like Israel and you find out 1%. Well, how much is 1%? And then multiply, and then you times it by 100. So either way is fine, gentlemen. Notice how basic this is. This is not regular maths. Calculate the number of persons who love cassava. How much person love cassava? Notice they didn't give us the percent. So what we have to do first? Very good, and subtract. So how much? The first thing we can find out is we can tell them cassava lovers equal 100 minus and subtract out all of that will add up. 12, 18, 16, 32. That's what? 30, 40, 78. So that's 22% of them love cassava. Sorry. And then we can just say, all right. Remember, we know say 1.8% is one person. If we're just following from what we already have there, 1.8 is one person. So 22% is x cross multiply. Cross multiply is just 22 over 1.8 give you x. Which is 12 parcel of cassava. Or somebody like Antoine where the unit 2 and Tristan, them probably can do so a little more show off and say if it's 22% love cassava and we have the total, 22% of that total must give you the 12, don't? So 0.22 times with 56. Either way is fine. Alright, I will get with 12 persons. Alright, so gentlemen, notice so far this boring. Just know, say, remember, for your test next week, remember, I make up the test. So you know nothing like this now come. So easy. Alright, look at this now. Part C. So, Aman, read this for us, please. Good. So what's one disadvantage? A, remember it says A. There are many disadvantages with continuous group data. What's one disadvantage with group data? Hence, so alright, we're not the data is not displayed in detail. So in that case, what we're really saying, Israel, is we can only compute estimates for our measures of central tendencies. That's what we're really trying to say. We need to have the actual values to get the exact mean. But since we don't have the exact values, we're going to work out what we call estimates now. So very good, Israel. We're not seeing all the data. So very good, Israel. That's a disadvantage. All right, now we're going to draw a histogram. It says on the grid provided on page 7, draw a clearly labeled histogram showing the information. And they said to use a scale 1 centimeter to represent 5 years. Remember, this goes on our x-axis time, and then on our y-axis 2 centimeter to represent 5 person. So when you draw an histogram, how do we draw a histogram again? Very good. Histogram is continuous bar. It's a continuous bar graph. So remember, you really and truly extend it from your lower class boundary from 4.5 to 14.5. All right. And what's the midpoint of 4.5 to 14.5? What's the midpoint? The midpoint of this interval, 5 to 14, 8.5. So that means this is 18.5 and so forth, going up by 10. All right, ready, let's go. So now we need to construct our histogram. First thing, notice the label, the axis for you straight away, so you're nice. And they said to use, how much them said to use on the X? I can't even remember. They told us to use, let's go back a look. 1 centimeter represent 5 years. So 1 centimeter represent 5. So each 2 centimeter represent 10. So 10, 20, 30, 40, 50. Then we reach, we're going up to 85. Where it disappear to? 10, 20, 30, 40, 50, 60, 70, 80. And of course, lastly, this is 85. So we use up the full graph. All right. And then, of course, they tell us that on the y-axis is 2 centimeter represent 5 person. So 2 centimeter represent 5 person. So 5, 10, 15, 20, 25, 30. Don't think we need to pass 30. Nope, don't need to pass 30. Max is 28. So gentlemen, remember your histogram is a continuous bar graph. So you're going to draw from 4.5 to 14.5. So what I like to do is I like to have the midpoint 8.5. I like to plot the midpoint against frequency. Follow. So 8.5. Don't like how down here look. Repeated. Like I retype it over. 10, 20, 30, 40, 50. So of course we need to go 7 to 8.5. So 8.5 on the X. This right here is 5, 6, 7, 8. So 8.5 is in between 8 and 9. And we're going up to 7. So this is 6, 7. Right here, so. Now, gentlemen, remember you draw the line from what? 4.5. Do not draw the line from 5 to 14 as you're going to get a bar chart. You don't want a bar chart. You can't go from 5 to 14. You go from 4.5 and then you go up to 14.5. So this is 14.5. Come down. That's it. Now the next one, going around, the next one is supposed to be midpoint 18.5, 16. So remember, you're not going to start at 15, and you start at 14.5 because it needs to be a continuous bar chart. So start from 14.5 to 24.5. So this is 4. Let me change the color so you can see the continuation. 14.5, and the frequency now is 16, so we'll go all the way up to 16. We'll go across. This is not underlined, guys. I know it look like it underlined to be 14, but bear with me. It's a rough sketch. To 24.5. So right here is 25, so we'll go down. In between, in the middle, that's 24.5. Alright? We're going to continue. Next midpoint is what? Good, so 28.5. Alright, so 28.5 to 28. Alright, so we'll go 20. You already. So 28.5 to 28. Good. Alright, so that would be in the middle. So 20. So we're going up now, 24.5. But the frequency is 28. So we'll go all the way up. This is 27 and a half. 28 is right here. Then we'll go across. I'll go into 34.5. This is 35, so we've gone too far. We'll reach right here. And we're good with that. Next one now. 34.5 to 44.5, but this time the frequency is 18. So we'll go 34, frequency is 18, so we'll look for 18. This is 18 going across. Right here says 18. I'm going over to 44.5. Right here says 44.5. We'll go down. Alright. Now we'll go 44.5 to 54.5. The frequency now is 13. So we'll go 13 is the frequency. 13 is here. I'm going across to 54.5. Alright, after that now, we're reaching the grandpa categories now, 55 to 64. So 10 now, 10 persons there. 10 is right here to 64.5. This is 64.5. Then the last one, we have, this is the biggest range, 65 to 84, 8 persons. So go up to 84.5. So how much persons? 6 or 8? 8. 8 persons. So this is 7.5. This would be 8. Each unit is going up by a half. So 84.5 right there. And that's it. How much marks they give away for this? 8 marks. Gentlemen, can you believe? 8 marks. But oh, we not clearly label it yet. We need to put our title. Histogram. Showing. What is histogram showing again? Distribution of ages of persons who booked on an island tour. So, persons, number of persons, visiting island tour. So, gentlemen, remember your title. You don't have to follow the traditional title where they tell you to write graph showing y versus x. You're not in prep school anymore. You're not in grade 9 no more. This is how they tell you to label it, don't? Graph showing y versus, that's basic school way. No, this is what your graph really showing you. Number of persons visiting island tour. That's a proper title. Nobody with no graph showing number of persons versus their age. Stop doing that now. We're not in grade 9 no more. That's when you just was learning to write title. Now they say use the histogram to estimate the mode. Now, gentlemen, good. Notice it says use the histogram and not the formula. So I'm happy that we would have done this question now. So how do you use the histogram? So gentlemen, this is how you use the histogram. What you're going to do is you're going to draw a straight line from this bar right here. Let me change the column. From the bar right before the modal class, you're going to draw it up to the top right here. Then the next thing you're going to do is the class just below the modal class right here. You draw up to the next one right there. Where they intersect, that is the mode. That is the mode, this x value. So where they intersect, let me draw a straight line passing through, go down to the x, so you can tell them what is the mode. So this particular x value is the mode. So what is the modal age? 30. That's the modal age. So gentlemen, this is how you find the mode using the histogram. Alright? All you do is just, draw x. And the x is from the class before the modal class and the class after the modal class. Pretty much what the histogram is doing is basically the same as what we do with the formula. So the modal age, so from our notice, they're giving you 1 point to see each of them line here that you draw. One for here, one for here, one for the line come down. So from the histogram, the they made modal age, but they say mode of ages. So the modal age is 30 years old. Now, gentlemen, just for the fun of it, let's say you wanted to use the formula and show off, right? So the mode would be equal to del 1 over del 1 plus del 2 times the class size C. So the lower class boundary of the modal class, that would be, modal class is the 24.5 to 34.5. So 24.5 plus del 1, the change is from 16 to 28, I believe that's 12, plus del 2, the change from 28 to 18 is 10. So del 2 is 10 multiplied by the class size. The class size going from 25 to 34, that's 34.5 minus 24.5, that should be 10. So we're going to put that in the calculator. Let's see if it gives us 30 like the histogram. Get the same 30? Beautiful. How much you get? How much? 29.5. So that means our histogram was slightly off. It wasn't perfect because what I wanted, 29.95, right? So our histogram wasn't perfect. The histogram should have given the histogram and the formula should have given the same thing. Because notice you're connecting what? The lower class boundary of the median class, you connect it to class after the median class, where they intersect, get the mode. It's actually is the formula that would translate onto the histogram. Literally, it is the formula would translate onto the histogram. So gentlemen, that means even though the true mode should have been 29.95, right? The true estimate. It should have been the true estimate. Our graph should have given us this, but notice we get 30. That means we're slightly off. All right, so you will make sure so when you're in the exam, you label up everything perfectly so you could have get that 29.95. So him could have say, whoa, it look like you do this spot on, man. But that is that, gentlemen. 30 is also fine if you give them 30. That's fine. Wouldn't lose any mark. But, you know, if everybody put 30 on the paper and Antoine alone put 29.95 from him graph, and everybody tie with 99, you know who gonna be the top student? Antoine. So them little thing there why I stress this, guys. Not that you're gonna lose any mark, but when they're gonna differentiate for placements, you want that. Alright. Number 2. It says state which of the following mean mode median. So may be determined from qualitative data. Which one is that? Which one is that? No, it says state which one, either mean mode or median. Which one can be determined from qualitative? Very good mode. Because let's say for example, all of we sit outside and we're gazing at cars and we see whole heap of red car, whole heap of blue, whole heap of yellow, and we say, maybe we want to say which color car we think passed the most today. Then the color car might say, oh, whole heap of blue did a pass. That's the mode, right? So good. Which one is affected by extreme values? The mean, very good. Affected by outliers the most, good. May have the largest value for a given set of data. What does this mean? May have the largest value, can be the mode, may be the mode, that's the mode, may, mode. Alright, median is always in the middle. Alright? It can be that, for example, the example I shared was, let's use Israel here. So Lamaria can get 85, 90, 95, and 90 upon him test, and average 90. So notice in Lamar get 85. Let me write it so we see. Lamar get 85, 90, 95, and 90. This will give Lamar average to be 90. But Israel can get 100, 100, 100, and 60. Israel mode is the highest value in the data set, but him average is what? 90. See it? Cool? Now the next one, part B, state which one of the range, interquartile range, and variance. Always remember what is variance, So notice, number one, is influenced most by extreme values. Which one is this? Range, very good. May be obtained by squaring the standard deviation. Variance, literally, look how that easy. Is the middle 50% of the distribution. Guys, I I told you this over and over. Middle 50 is what? Interquartile range. Q3 minus Q1. The 75th percentile of the data minus the 25th percentile of the data give you the middle 50 percentile of the data. That's what interquartile range does. Isn't that so? That's it. Easy. Basic. Alright. Oh no, I forgot to change the test, guys. I gave something like this, but since we're gonna do it now, I will change the test that I set already. I didn't want to get exposed to a question like this yet, but since we're gonna do it together, I'm gonna have to change the test. So this question here, it says calculate estimates for the mean. So they tell you that the sum of x minus 45, key thing, the sum of x minus 45 is negative 148, and the sum of x minus bar x squared is 3089. Estimate for the mean is what? Bar x, and bar x is the sum of x over n. We know n is 36, but they give us the sum of x minus 45. How we gonna do that now? How we gonna do this? How we going to do this? Alright, so gentlemen, see it here, it come back again. This is now the sum of x minus 45 is the same as the sum of x minus the sum of 45. The sum of x is the same as the sum of x minus the sum of 45, and that is negative 148. But gentlemen, remember n is 36. So if you're adding 1 to 36, remember this is 36 data values. If you add 1 to 36 45 times, what you gonna get? You're adding 45 36 times. What you gonna get? You just multiply them good. So what we end up get? Very good. So minus 1620 equal negative 148. Transpose now. So the sum of x is 1620 minus 148. Work that out for me. Tell me what you get. 1472. So now we can tell them that the mean bar x is equal to the sum of x over n, which is 1472 divided by 36, which is all right, 40.8. Good. That's it. That wasn't bad. Yeah. All right, now this standard deviation. Now, gentlemen, all right, a sample of 36 data points. A what? A sample. So which formula we're gonna use? N minus 1. Very good. N minus 1. Now, looking at this, as I say, this is the beautiful thing, all right? We know bar x now. We know bar x. So, gentlemen, there's two ways you can do this. All right. You always try to stay away from too much algebra. All right, because this is not pure, but we can do it that way as well. So, first thing, notice how important this is. We're gonna have to break that out as this is now the sum. We need to find the sum of xi squared. That's our aim from this part. That's why they give us the square. All right. So as much as applied easy, you realize I still try to put in little maths in it, right? So this is first term square minus twice the product of the two plus second term square. And 45 square is 45 square. Oh boy. Past 30, so hard to remember. 2205. Alright. Oh, sorry for Aman. Aman, what we did was we multiply x minus 45 times x minus 45. Okay? Alright, so sorry I skipped that step. But that's fine. So that's what we did. Now in that case now, gentlemen, we can break it out now, and this is now the sum of x squared minus 90 times the sum of x, and this is plus the sum of 2025. But remember, we're going from 1 to 36. If we're adding 2025 36 times, what we get? $72,900. Very good. Now look at this, Lamario. So this is the sum of x squared minus, we know the sum of x. We got the sum of x already to be 1472, don't? So work out 90 times 1472 for me. So now we have sum of x squared minus, how much you say? 1000 what? 113,000? Oh, 132,000. How much? 480 plus the 72,900. All of that would say equal 3,089. So we need the sum of x squared. So this is now the sum of x squared is equal to bring everything to the other side. 13480 plus 3,089 minus 72,900. Work that out for me now. Must be 60 something or 70 something or 50 something thousand. How much? 100 and can be more. When you add 3,000 to 132,000, that's 135,000 something. 135,000 something minus 72 thousand. That must be 60 something or 50 something thousand. Yeah, fix that. Jaden, how much you get when you put in the calculator? This part, 132,480 plus 3,089 minus 72,900. 62,600 and how much? Alright, now we need to can use the formula that the standard deviation, remember, gentlemen, you're not showing them the formula, they don't get the marks of the formula because they're going to tell you it's on the formula sheet. It's now the square root of the sum of xi squared, which is 62,667 minus the sum of x, which you'll find in part 1 already, 1472 square over n. N is 36 over n minus 1. N minus 1 is 35. Punch that in the calculator. That's all. Easy. So 62,600. That's what you got when you put in the calculator, right? Oh, 69. Sorry. 69,667. All right. Thank you. How much? 69,667 or 69? Oh, 9 here, but 2 here. 2 here, right? All right, but 9 there. Okay, no problem. All right. When you put everything, 8.42. So that's the estimate of our standard deviation, 8.42. Easy. All right. So after we do all of that now, gentlemen, notice what they say now. I love these questions. It says another data value x equal 29 was added. Calculate the values for the mean and the standard deviation. So now we need to find the new mean and the new standard deviation. Don't know why they're giving 5 marks. So gentlemen, remember, the sum of the 36 scores, we found that to be 1,472, don't? Yeah? So the new mean now, look at this now, the new mean, so bar xn mean the new mean is them 36 score the way add up, plus the new score, so Israel, follow, we couldn't just average it to it. That's why I gave the question like that earlier. So now we have to add that 29, then divide by the total now, which is 37. Make sense? So the new mean is what? 1472 plus 29 divided by 37. That's 40.57. We get that? Or 40.6. So what was the old mean? 40 point something too. 40.8. So it only drop it by 0.2. Now, gentlemen, what I want you to do now is add the 29 and write that down, So write down what's the new sum from 1 to 37. What's the new sum from 1 to 37? 29 and 142. How much? 15. 1,501. Good. Thank you, Jaden. Now, gentlemen, now we need the sum from 1 to 37 of x squared. So in that case now, what we need now, look what we're going to do. So now we need to add 29 squared to the 62,667. Does that make sense? After, oh, 69. Why I keep with 7? I keep seeing 7. Sorry. 9. So add 29 squared to this. So that will give us now our new sum, which is 1 to 37 of now x squared. Add them for me. 63,510. So now the new standard deviation is now the square root of 63,510 minus the new xi 1501 square over n 37 now divided by 36. I'll punch that in. Oh, I should have put fraction button first. Square root fraction button 63510 minus another fraction button 1501 square over 37 over 36. Bam. It don't even change. Huh? Yeah, but I mean 29. I mean 29 barely deviated from 40. That's like 11. So that's why the deviation hardly gonna change. So now it's 8.53. Hardly do anything to it. Right? And so realize this was probably the most question that involved math in it, right? It was the most maths that we do. Then now this is the last question now in module one. So gentlemen, your test gonna look something like this. Of course, mine gonna be a little more nicer because I build it nice. This built from scratch, so you can't find this anywhere. Nice. Alright, so that's why you have these paper to practice to help you. Alright. So this now it says determine the median number of marbles per packet. What's the median? All right, so gentlemen, that is why I love when you write the cumulative frequency. So you have 2 here, then 2 and 9 is 11, then 11 and 19 is 30. That way we can identify where 25.5 would be. 25.5 in here. So the median is equal to 15. Now, gentlemen, please write this on your paper. Notice it worked 2 marks. So if you just write median equal 15, 1 mark, you have to do like what Jaden say. Show them say it's a half n plus 1 to get the median position. So very good, Jaden. I heard you say it. 50, 50 plus 1 divided by 2. You have to show them that part too. Determine the mode. What's the mode? For this distribution, look at this one. Good enough. This is not, yes, it's group, but it is not continuous group. Remember, we look at discontinuous and continuous group data. Exactly, the mode is just 15. Right? Yeah. Now, it says calculate the mean. Tristan, how we gonna find the mean? Tristan, how we gonna find the mean? It is grouped. Yeah. Summation of f. Yeah. Alright, so Tristan, what's the sum of fx? So you have your x and you have your f. So you need to work out f times x now, don't? So 13 times 2, 14 times 9. I believe that's 126. Yeah, 15 times 19. That is what? 285. Yeah, 15 away from 300. 16 times 12. That's 196. 192. Yeah, not, yeah. And 17 times 8. That's, yeah, 136. Okay, so add those for me now. So 26 plus 126 plus 285 plus 192 plus 136 You divide it by the sum of f, and the sum of f is 50. They told us it was 50. 15 point? 15.3. That's the mean. Easy. Now it says describe the shape of the distribution. What's the shape of this distribution? Notice you know the mean is 15.5. 15.3, sorry, the mode is 15 and the median is also 15. How are you going to describe this shape? What do we mean by shape of distribution? It's positively skewed, mean minus mode. But in this case, we're going to say the distribution is either going to use the word slightly positively skewed or use the word relatively positively skewed. We did that last week, Tristan, so remember, mean minus mode is skewness. This is skewness formula, mean minus mode. So if skewness, when you work out oh yes, 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 with the box plot we did. Yeah, so it's when the formula mean minus mode, when it's greater than 0, it is positively skewed. When it is less than 0, it is negatively skewed. When it's equal to 0, it is symmetric. It's slightly positively skewed or relatively positively skewed. And that is because you realize mean mode median, roughly the same, 15, don't? So we'll say slightly positively skewed. And that's it. So module 1 done. Isn't this paper very easy? Then we get into add math stuff again. Tree diagram. Easy, don't? Contingency table. So gentlemen, this was easy, don't? Repeat. Easier than expected. So gentlemen, before we go, just remember, I want you all to do them questionnaire. When you do all of them, when you do all of them, I can either post it in the classroom, the solution, or I can send you the solution individually. But I want to know you do the question them first. Do the question them first for this worksheet, sorry. No. Oh, I close it. For the worksheet I upload today. Do all of them where you work out mean mode, median, standard deviation, skewness, do everything. Variance, do all of them. Secondly, remember, next week you're getting a test. Remember, you're getting a 6 weekly test and it is coming on your report. Next thing, you're going to get a homework. And the homework, remember, it's going to be on everything in module 1. Alright? It's not going to, I'm going to allow us to do it in pairs. So we can do the homework in pairs. Alright? Alright. And gentlemen, remember, face-to-face classes, $1,000 for next week. Alright? Alright, so please study for the test next week. Please, I'm begging you all. You want to come and do it Can you come and do it Saturday? I'd have SAT Saturday. I could just allow you to do it. Because Mr. Winter will have the applied math papers printed. I'll just go collect it from him and give you Saturday. Alright. Alright, so gentlemen, see you tomorrow. Antoine, good to see you are here. I have the class recorded, so I'll just upload it in the stream, alright?